Hello all. A warm welcome to our today's webinar, The Importance of Battery Monitoring into IT Infrastructure. My name is Simon Rajman and I'm the Marketing Manager of Robotina. Today's webinars we arrange in a Simon Sinex style in the BTMS golden cycle. So following the step by answering questions, what we are doing, how we're doing and why we are doing. Of course, in all the content of battery monitoring. So addressing the business aspect, the necessity, the state of technology, and lastly, showing you some real cases of projects from Middle East region. First thing first, today's speakers will be David Palcic, CEO of Robotina, describing the essentials and what future holds, followed by Dusan Janic, product manager, describing the necessity of and the approach of battery monitoring. The next speaker will be Goran Kocijancic, senior product development, and at the end, Fakhri Valikarim, general manager of Robotina Middle East. For the topics, to summarize again, the topics are the current state of battery monitoring system, the future of battery monitoring system, the importance and the right approach, the state of the technology of battery monitoring system, BTMS of Robotina, and cases of deployment of our solution. Regarding the potential questions, you are welcome to send them to us to the email address webinar@robotina.com. That will be present in every presentation, in the footer and also in the end of every presentation. This way, our assistant will make sure the right question reaches the right speaker. To conclude, again, thank you for your time and for joining us. And now I welcome the first speaker, Mr. David Palcic, Robotina CEO. Mr. Palcic, feel free to take the screen.
Thank you very much, Simon, but you have to allow me to share the screen because I'm allowed to speak, but not yet allowed to share the screen. So please do it. And in the meantime, I'd like to say hello to everybody. Hello from in this webinar way. I'm addressing you from our Dubai office at this moment. So if I give you a still hot here, if you have a look over the window. And but I would also like to invite you to visit us physically in the next 2 months. There will be quite some events which will allow us and you to meet together. The first one being in Frankfurt, Germany, Light and Building exhibition, where we will show also the BTMS. And second will be the GITEX back here in Dubai, where we will also be here with energy management and battery management. And of course, last but not least, the most important data center event for Asia in October in Singapore, Marina Bay Sands. We will also be introducing our EMS and BMS. So, Simon, are we getting any closer?
Yes, you should share it now.
No, sorry, but it's still not there. So, so I'm not able yet to share this. I will continue without the presentations. So please make sure that the other things can work for the other parts of the team who may have more important things to say.
Now, please try it now.
I can try it now. Yes, this should work right now, and it is here. Okay, I think my presentation is here. So, as Simon said, the first answer I want to answer to you is why. You know, a normal question from those who invest in data centers or invest in critical infrastructure will always be, I bought millions of dollars of equipment, and why do I have to buy also the BTMS? And the reason is very, very simple. First of all, 80% of failures in the UPSs occur in the battery side. And second, very good reason, it's all about money. BTMS and energy management systems save you money. And they have the fastest ROI out from all the parts of the data centers. And they help to protect very expensive systems, and even more, they help to protect the very expensive businesses. And last but not least, they are very cooperative, so they can connect with the building management systems, they can connect with the other energy management systems, they can connect to the facility management, and they are simple to deploy. You can deploy them, or in fact, you should deploy them in every phase of the project, either at the beginning when you construct the data center, or as a retrofit. So easy to use, money saving, and giving you a lot of information which will help you. Now, just to pinpoint the position of the BTMS in the EMS. EMS is an energy management system. Energy management system takes care about all your energy in whatever the building, whatever the facility is. So it takes care about the sources, it works with consumers and distribution, and it adds the functionality. Now, the battery is the most ignored high-risk point, and colleagues will tell you more about this later on. But not only, battery is also something that gives more opportunity than just giving the energy backup or the power backup. But so this is about what it is and why you should seriously consider energy management system and BTMS. Now it's my task and my pleasure to introduce you the future, to give you a touch of the future. So where are we going and where we will be soon? Colleagues will tell you where we are, and we will give you more details about the existing system. I'm telling you where we are going. Now, when we talk about advanced functionality, we have to touch three more main areas: the area of BTMS, the area of energy management system, and the integration of this system into the intelligent network operation centers, or central command centers. Call it the way you like it. First, let's talk about BTMS. Where is the future of our products going? And there are three main directions. One is predictive maintenance. So we are already now able to tell you exactly which battery failed. We are even already now able to tell you which battery is going to fail. But very soon, we will be able to tell you when the battery is going to fail. And this will dramatically improve or will reduce your expenses, because you can plan and you can do better maintenance. The second direction, where our R&D and new functionality is focused on, is managing the state of charge. State of charge does not only tell you how much energy you have there, and can not only tell you how long you will be able to operate your center from the UPS, but it also gives you the opportunity for the demand modeling and for using the cheapest possible energy source, which I will tell you something about later. And of course, the number three is how to support the maintenance. So how we track the performance of the individual battery, how we do the analytics of individual battery, and how we help you to identify and to track the actions of the people. Of course, in the connection with the maintenance support systems like Maximo or others. And the last direction I want to talk about, or the second direction I want to talk about, is energy. You know, first importance of our energy or power is the reliability. So we are adding tools that are helping to increase the reliability. So online analysis of all power sources and online analysis of all distribution boards and distribution lines. So this can maximize the quality of your power, which is the most important. Second is the cost. We are adding in our energy management system, or we already are there, the possibility to use the cheapest possible available energy, either from the grid 1 or from the grid 2 or from the grid 3 or from the whatever, from the batteries. And of course, we will allow the optimization of multiple centers, a fleet of centers, in the relation to the energy suppliers. We are adding optimization of auxiliary systems, specifically HVAC, and we even introduced the possibility of thermal storage, so chill the water and when the electricity is cheap or available, and use it later on. Plus, at the number 4, we added a lot of rules that help improving the performance, and we are fine-tuning the rules with the parameters that we get from the machine learning and artificial intelligence algorithms. Now, of course, all this information needs to end up in the network operations center, where one person or team of the person is able to operate all of your assets, all of your centers, and of course, in connection to other systems like ERP for issuing the invoices, like SCADA, like facility management support systems, and so on and so on. So these are the 3 main directions we are going, but there is one more quick discussion we have to have together, and this is about batteries. People are asking us, what about lithium ion? You know, lithium ion is, and all the technologies, lithium phosphate and all the things, are coming very strongly, but the traditional solutions like lead acid and the derivatives are still on the market. And we believe this will be so for the next 5 or 10 years. So when we talk about the lithium ion battery, also lithium ion battery needs the battery monitoring. But lithium ion battery has normally the battery management system integrated, so we don't need to add this kind of sensors to the lithium ion battery, but we need to integrate lithium ion battery in our gateways, in our systems, and in all our intelligent software, because it's bringing the important benefits to the system. So that's about lithium ion. Sorry for going fast through, but we want to keep our timings. So, and the last one, you know, data centers are not always built in the nice buildings. In some areas, like remote areas, undeveloped areas, after disaster areas, you need to have mobile data centers. And we developed the mobile data center without data center. So everything you need is there. You just need to put your computers in and start the operation of your mobile data centers. Our colleagues will be happy to tell you more about this. So, not to forget your questions to webinar@robotina.com. And now it's my pleasure to introduce the next speaker. This is Dusan Janic, our product manager for the BTMS. And Dusan, the stage is, of course, yours. Thank you very much.
Thank you, David. So I hope that you all see my screen. If not, somebody will send me an email. As David mentioned, my name is Dusan Janic. I am a product manager for BTMS in Robotina and also some other products. And today I would like to explain what our BTMS is doing, how is it doing, and also to whom is intended to. So if we start first to who is intended, it is intended for everybody that needs large but secure and reliable UPS. So if we go further, where we see the issues with the present or standard, I call it standard UPSs. So in the standard UPS, we are monitoring only the total voltage of battery pack. So if the voltage is not nominal, we actually don't know what is happening. So it's failing one battery, more batteries, or it's just not charging. We get some information, but not all what we need. And even greater issue could be that actually when the UPS or actually batteries are not under a load, then some faults will not arise. They will arise only when we will request the power from the UPS and the current will start to flow. And then this problem will arise, but there is already too late because we need this power. So it is like a little bit old cars when you have the battery, but that was failing, but you didn't know. The lights were okay, the music was playing, but when you try to start the car, then nothing happened. So that was quite challenging. So we are addressing such situation when there are tens or hundreds of batteries, and it's actually $1 million question, which battery is the weakest link. So which will fail first, and then it will bring down the string, and you won't have the power that you need. What is the answer? The answer is monitoring the battery, the UPS on a battery level. And there are several ways to do it. And actually the wrong way is doing like this. We don't want our customers because it at least is not tasteful. So let's say we are doing it in this way. And we will compare it with the standard UPSs. So we are measuring state of charge of battery string in real time, and we can have on one gateway 32 strings. So you get this information right on the time, and with human in maintenance, it's not very efficient, and with the standard UPS, you get also this information, but we are also measuring the state of charge for each battery individually, also in the real time, and this information with the standard UPS is not available. Then we are also measuring or calculating the state of health for each battery. So we are measuring the voltage, the current, and calculating some other stuff, the temperature also, and you have this information in real time, not available with standard UPSs. When something is not nominal, let's say it's going a little bit wrong, the alarm is triggered and also recorded. And you get alarm on your phone with a short message, or you get the email. And this is happening also in real time. Then we are performing scheduled maintenance, and the report is available over the web interface of our system. And so you can look it, you see how it's going, you can compare it with history data, and so you are prepared for what is coming. Not available with the standard UPS. Then when something is wrong, we are changing the color of LED light on our cell sensor or battery sensor, whether it is on each battery or cell. It depends how your UPS is constructed. And it changes from green to red, so you will be able very quickly to find it, maybe measure it, maybe change it. So your UPS will be in the standard, in the optimal condition. Then the battery balancing maintenance. So when you're charging the batteries, not all the batteries are charged at precise same moment. So we are discharging a little bit the batteries that are already charged. So the not fully charged batteries can charge to the, let's say, optimal voltage or capacity. So again, your the complete UPS system will be in the optimal condition when you will need it. Again, similar as fast location replacement alarm, when our system detects that you need to replace the battery, it will send an alarm, and also the color of the LED will change. And last on this list, not the last as functionality, but for me, one of the most important things, string disconnect. So when one battery in the string reaches higher resistance than others, then this battery, when the current will start to flow, will start to heat more than other batteries. And since the current can be quite high, and this power increments with the square of the current, this temperature rise can be quite significant, and it can also cause the explosion and the fire of the battery. So we are measuring not only the current, but also the temperature of each battery or cell. And we are disconnecting the string if something goes wrong in this way. In this way, we are preventing fire and explosion and greater damage to the system, or even broader. And for me, this is one of the most important things that is happening. Oh, sorry. So there are other issues with the battery that can be addressed with our system. So rise in the ambient temperature that can shorten battery life. It depends of the chemistry and so on, but we are measuring the not battery, also the ambient temperature. So then overcharge for the individual battery, and what can cause the several problems with the batteries, like battery inflate, battery leakage, and so on. Then undercharge that leads to not having the UPS in optimal state, and also batteries are declining faster, and state of health is decreasing. Then this real float voltage is the voltage when the battery is kept when it's already charged. So when it's charging, is little bit the voltage is a little bit higher, but then if we want to keep it fully charged, we keep the batteries on a little bit lower voltage. But if this voltage is only 5% from the optimal value, then this can significantly shorten battery life. This depends very much on the chemistry of the battery, and each battery has type of battery has its own float voltage. And also short circuit inside battery, when the battery can explode. Let's go further. Where is the value of battery monitoring? Certainly a reduced cost of the labor and increased efficiency, because we know what is happening. All the data are available online all the time. You just need to check and then you address the right battery and the problem. So you can fastly find your battery that is failing because of the lights that are on the cell sensors. Altogether brings that the battery packs are quite consistent and the whole system is working optimally. And as I mentioned, for me, preventing battery explosion and fire is the greatest value. What we are doing and how this solution is done. It's a real-time system, and it can be remote and connected. It consists of the hardware and software, so some special hardware and software is developed by us. It can be on-site or in the cloud. Cloud can be our own cloud, or let's say private cloud or commercial cloud. From out of the box, we are supporting Modbus communication, and with this we can integrate it with existing SCADA systems, or where can we also integrate it with some IT solutions, and we can also construct new SCADA if this is what the customer wants. We are also working with our customers before purchase, so with consulting. Then we deliver, and we then offer the assistance for the system. And this is all from my side. I hope that I was not too fast. Please send the questions to webinar@robotina.com. And now I will introduce my colleague, the head of the development of BTMS, Mr. Goran Kocijancic. So, Goran. Goran, are you here? So, if
yes, sorry, I'm here. Just forget to enable the microphone.
Okay, no problem. So the screen is yours.
Thank you, Dusan. I'm Goran Kocijancic, responsible for the technical development of the BTMS system, and I will briefly introduce you to the more technical side of the BTMS system, let's say. So, in principle, larger UPS systems have several batteries connected in series in so-called strings. The UPS can have several strings connected to the UPS in parallel. The basis of BTMS system is formed by battery sensor or cell sensor, which measure voltage, resistance, and temperature of batteries and calculate state of charge, state of health for each battery. In addition, they enable also battery balancing. They have built-in LED indicator to quickly locate batteries with issues, with problems. Up to 120 battery sensors are connected to a BTMS string sensor, which measure the string current using a Hall sensor. And the basic task of the string sensor is to collect the data from the battery sensors and calculate the parameters related to the string. These are string voltage, current, string state, so charging, discharging, etc., state of charge, and battery balance. Just like battery sensor, also the string sensor has an LED indicator to show the state of the string. Up to 32 string sensors are connected to the gateway via separate BTMS local network. The gateway combines the data from string sensors to UPS level. It displays the data in the web user interface. In addition, to viewing real-time data, also stores the data in local database and displays history in the form of time plots and event tables. When the battery issue is detected, it generates an alarm that can be sent via SMS through built-in GSM modem or via email. It also has built-in Modbus TCP/IP server, which allows the external applications to access all data from BTMS gateway. In addition, it ensures a safe and reliable connection to the cloud service via the facility network. The cloud service enables a more detailed analysis and prediction of possible battery faults. The BTMS system can be upgraded with master controller, which allows the connection of local graphical user interface, so local graphical display, which show all the data from the data center, from the gateway. The ambient temperature and humidity sensor, and the module with digital inputs and outputs that allow the connection of additional sensor, let's say leakage, gases, etc., and an alarm output for each string, used for switching off the string with an error or for additional alarm indicator. We paid special attention to simple wiring that enables fast and reliable implementation of the BTMS system. The battery sensors are interconnected with detachable cables with Ariot 9 telephone plugs. They are connected to the batteries with pre-prepared cables that have USPADs on the battery side and detachable connectors on the sensor side. The Hall sensor is connected to the string sensor via the included cable with detachable connectors on both ends. String sensors and the gateway are connected to classic Ethernet network using standard network cables and standard network switch. The cables for connecting the modules to the master controller are pre-prepared and included. And at least the touch panel and the ambient sensor are wired using a standard 4-core data cable as 2.2.08 or similar, commonly used for fire security or ABE installations. Commissioning. So commissioning consists basically of 3 steps. The first thing is to set up the gateway system. These are network settings, time servers and local time settings, user management, email server setting, GSM modem, and project setting. This is project name, icon, etc. The second step is to configure the modules connected to the system. So this is the management of string sensors and battery sensors and all additional modules connected to master controller. And the last step is to set battery string sensor settings. In this step, we adapt the system to the used batteries and to the actual system topology. It also allows adjusting alarm limits and to set actions when alarm occur. All the settings can be easy backup to the local computer and reloaded to another string or even another gateway. So very quick deploy. In the following, I will briefly show the basic features of the web user interface. To use the web interface, each user must first log in. There are two types of user: ordinary users who can just monitor the operation of the BTMS system, and administrators who can also change the system settings. On the left side, there is a tree structure, which also serves as menu for displaying the various parts of the system. The main display is organized on several subpages. Switching between subpages is done with the tabs on top. For any table displayed or any graph displayed, there is possibility to download the CSV file with all displayed data for additional analysis or any need. So we have the real-time data display, which is logically organized for several devices and basically consists of the table display of the real-time data and some bar graphs, which simplify comparing the data, and it's very easy to change or to switch the data displays of voltage, current, state of charge, and so on. Then we have history data, also organized by devices, and the data is very nice presented, and it allows to see the history of the parameter measured, and it also allows easy switching of the data displayed and easy navigation through time axis. All data is kept for a period of 1 year, after which is automatically deleted. Sure, the data can be backed up and stored permanently, but not on device, on gateway. Discharge data. So BTMS gateway automatically detects and records all battery discharge events. It enables an easy overview of these events and analysis of what is happening on strings or on individual batteries during this discharge. The alarming. So all alarms are fully configurable and automatically logged. The interface allows a quick overview of active and past alarms. It also allows you to review all messages sent, SMS and emails, and the status of sent messages that were sent when the alarm occurred. So, thank you for your attention, and don't forget to send questions to webinar@robotina.com. The next speaker is Mr. Fakhri Valikarim, Executive Director of Robotina Middle East. Mr. Fakhri.
Microphone, Fakhri. switch the microphone on, please.
Thanks, Goran.
Welcome.
Okay. Sorry for this hiccup. I hope you can see the presentation on the screen. Good afternoon, everybody. I'm sure by now you got a good insight in terms of what the benefits and features of Robotina battery monitoring system is about. But it's very important also to share with you some of the experiences we have on the site. What happens on site? What are the challenges on site? And once the system is commissioned, then what are the real benefits for the customer's experiences? So let's look at some of the sites we have done in the region. For the project in Dubai we have done, we have installed 2,700 battery sensors covering 23 UPSs in 8 different UPS rooms. You can see how the battery sensors are installed on the face of the battery. It's easy to install, it's easy to connect, and it's quite user-friendly. We also offered remote web connectivity, which I'll explain to you a bit later. We also, on the same job, we have installed the user interface, the HMI interfaces in every UPS rooms, which enables the operator to go to the HMI, touch the screen, is a touch screen panel, and view every UPS, every strings, every battery sensors, and they view different form of reports. And we'll later describe how we customize the reports as well based on the customer requirements. So the HMI interfaces enables the operator to look at the system overall details in terms of fault, in terms of any operational issue, in terms of how the system is functioning. For a project in Abu Dhabi we recently completed, we installed 5,000 battery sensors. And it covers around 15 UPS rooms installed with 45 UPSs. If you look at the circle marked, marking the sensor, that's a temperature humidity sensor. So what I'm trying to say is we also monitor the environmental system onto the same controller. We don't require dual system, 2 systems to connect separately the battery monitoring system and the environmental monitoring. We connect all the devices on the same controller, enabling the operator to have one system, one functionality. We also offer in the graphs below, in the charts below, it's feasible, it's possible for you to know the details by connecting your PC onto the building network, which is a feature of remote web connectivity. This is a tremendous good feature which enables the operator not to go to the UPS room and look at the HMI to check the system functionality. They can log into any part of the building network, connect the PC, and view the system details. There is another job ongoing in Dubai, which is under deployment for partner Siemens. The system is again covering some 4,000 battery sensors and also involves remote web connectivity, temperature, humidity monitoring systems. We can also monitor, apart from temperature, humidity, any other environmental aspects as well. Let's understand what are the challenges and what are the benefits the customer looks at after once the system is commissioned and handed over. The most common problem what we see on the site is batteries are the last fix because of the delivery times, because of transportation times, because of the charging characteristics, etc. Batteries are installed on the site in the last stage. And then we come under pressure in terms of completing the installation because we need to install battery sensors on every battery, right? So we given a fixed time window that within so much of time frame, we need to complete the installation. So that's one thing which the contractor, the integrator, ourselves, we all need to keep in mind in terms of how quickly and how efficiently we can plan the installation. The positives are Because the sensors are so easy to install, hence we overcome this problem. Hence we overcome this challenge. It's a very plug and play installation of the battery sensor on the top of the battery. The configuration is plug and play. Once the installation is done neatly, cleanly, and smartly, then the system is plug and play configurable. Customization of reports is very much possible once the system is up and running. And 5,000 sensor system we commissioned within 1 week time. You can imagine the installation done, the commissioning done, the customization of reports done, and system is up. Some few snags might be there here and there, but by and large, system is up and running and the client gets the added value of the system operation. Even the loose cable from any single battery brings an alarm from exactly that concerned battery. Remote web connectivity talked about, it's a very important feature because it allows you access from anywhere in the building. We provide, very importantly, impedance measurement, which provides the status of health of the batteries. Environmental monitoring is one important aspect, and system is very much capable and proven for integration. Siemens integrated with a Desigo BTMS system, and any other solutions can be integrated. And we also provide power analysis reports. So that's the practical side of it. There's the side experience we had. And the benefits, what we clearly believe the client will enjoy once the system is in operation and use. So that concludes my presentation, and I'll pass it on to Dusan, who will be open for questions. I mean, you can put your questions on webinar@robotina.com, and any more queries, any more clarifications you may have, you can always contact the local offices here. And we'll be more than happy to clarify. We have a solution, we have example, we have references with very reputed clients. Gulf Data Hub was housing Microsoft and many major clients in their premises. Sident Power is a contractor who has been a reputed installer in the region, and Siemens have been a very useful partner. This relationship is quite strong, quite proven, and quite successful as far as the data centers are concerned. And we look forward for getting in more opportunities. Any more queries, any more clarifications you may have, please contact us. Thank you very much. Thank you, Dusan. Over to you.
Thank you, Fakhri. I see that previously I didn't switch on the camera, so it looks like I missed the button. So sorry for that. But now you can see me, and now I will go to the questions. I see that there is already something happening with the chat, but actually we would like to ask you to send these questions to webinar@robotina.com. So then we can look who is the most suitable for the answer. Let me check. I was looking before. Okay. And just a moment. First question. It's opening a little bit slower. So you mentioned that balancing with the battery sensors. What is it and meant to do? Oh, I think that we have said about something about this, but maybe Goran, please, can you go a little bit deeper with this?
So, can you repeat the question exactly? Because I was looking the chat a little bit. Microphone.
Sorry, it is a little bit slow, sorry. Yes, it's busy in the chat. I see. Just to open the. Okay, you mentioned it, balancing with the battery sensor. What is it and what is it for?
Okay. Thank you. So, because the batteries are connected on series and the UPS is charging the series of the battery, because of small differences between batteries, even if they are all basically the same, are not charged exactly the same. So this results in that some batteries are charged more and has higher voltage, and some batteries are charged less, and this is not optimal for the capacity of the whole string. So the string sensor, in combination with battery sensors, analyzes the voltages of the each battery on the string and discharge the batteries that are charged more than other. So the UPS is able then to charge again the whole string and to over time to charge all the batteries on the optimal value. And that's basically the balancing function what is doing.
Okay, thank you, Goran.
Welcome.
So now we have a question for David. It's actually addressed to him. Just I can read. David, do you hear me? I know that you are quite busy in the chat.
I do hear you, don't worry. So
okay, so the question is, we know that Lithium Battery has built-in battery management system. Why do we need battery management? I remember that you addressed this, but as Goran, maybe you can go a little bit deeper.
Okay, you know that the lithium-ion batteries need a battery management system built in each battery to exist. So each lithium-ion battery is made of several cells, and these cells are connected between them. And the battery management system, being active or being passive, makes sure this balancing happens on the battery level, makes sure that all these protections are implemented in the proper way, because as you know, the lithium-ion batteries are fantastic batteries, but they have some nasty behaviors, like they tend to catch fire, for example, by themselves sometimes. So battery management system take cares about this battery. And of course, this battery management system can measure the key parameters of the battery itself. But that's all what it can do. And from here on, so compared to the lead acid, you don't need to build this orange sensor directly on the battery package, but we get this data from each and every lithium-ion battery from typically via CAN, so Control Area Network Protocol, which allows us to get this in real time. But all the functionalities, so monitoring, analytics, alarming, reporting, integration in the upper systems, integration in the energy management systems, integration with SCADA, as you were talking, integration with the facility management, all these functionalities, it's still needed. And this is achieved then by our system. So to make short, if you use the lithium-ion batteries, then you don't need to buy the battery sensors and string sensors. All other things remain the same. At the end, but not the least important, you can always combine lithium-ion batteries and traditional batteries, connect them to the gateway, and bring the data from everything to the same user interface, which is extremely important. So I think this is about that. If anybody has more questions about this specific topic, please feel free to send an email to our team, and we will be happy to discuss it with you.
Okay, thank you, David. So, and now actually, just great. It's what was the failure rate of devices during the commissioning stage? Probably in Dubai or in Abu Dhabi.
An interesting question indeed.
Yes, I also don't know the answer. So, Fakhri, can you answer this?
Yeah, it's around, I mean, totally both the sites together in Dubai and Abu Dhabi, we had around 5 to 6 sensors replaced out of the total 6,500 sensors installed. And we didn't have any replacement, any failures on the controllers or power supply or string sensors, any other devices, just 4 or 5 battery sensors replaced. That's about it.
Okay. I hope that I think it's very well. So, and I also see
maybe I can
question.
add, Dusan,
Yes.
if you allow me to add one piece of information. We are talking about MTBF and MTTF calculation, so mean time to failure, mean time between failure, at the industrial grade level, which is we are talking 100,000 hours, is the statistical relevant information. Maybe this can help to somebody to try to understand the ranking of this kind of system. Thanks.
Thank you. And I see another question. It's about industrial protocol. So yes, Modbus was mentioned. What other protocols are okay? So I will try to answer this because Modbus TCP is already built in. Then MQTT is also built in, but it's somehow blocked, and this won't be an issue to open it. Then actually, if you need, let's say, BACnet, because there are a lot of protocols out there. You can use some protocol converter from nearly all converters. Starts with Modbus. Can be also others, but I know that from Modbus to BACnet it's not any problem. It's a very small device and it works perfectly. Then we are also thinking about SNMP that will be actually targeted for the use in IT, because SNMP is quite used in IT. And as I mentioned there, for others, we can use protocol converter there. Not expensive and works perfectly. And so
maybe I add on the
yes.
cloud level, there is of course the possibility
API
to reach through API. Yes.
Sorry, I forgot this. Yes, from to the connection to the cloud with use of our API. I'm always thinking from the site, not cloud to cloud. Okay, then I don't know if there are some other stuff in the chat. Not.
No, maybe Dusan, just if you allow me to add something, we tried, me and our team tried to answer some questions that came in the chat, even if we agreed that the main answer channel will be the email. And I believe that we are slowly reaching the end of this session. So before bidding goodbye and saying farewell, I would just repeat 2, 3, 4 most important things. First of all, whatever question you may have, send it to us and reach to us individually so we can discuss your specific requirements, your specific questions. This is very important. Second, we will be all really happy to see you face to face in the events, which are plenty of them in the next 2 months. And before they close the traveling and everything again, let's meet, let's discuss your issues, and let's work together towards best possible power reliability, because this is our target. We want to work with you and to help you implementing the best functionality in your system. At the end, of course, we are developing this product, so we are able to work with specialists to provide you very specific requirements and to fulfill all the needs. But this is another story to be discussed another time. And thank you very much to everybody. Thank you to all the presenters. You did a great job. And talk soon. Take care. Bye-bye from all of us. Thank you.
Yes, thanks from my side. Please don't hesitate to contact us on our webinar email, or you can also send it to info@robotina.com. We will be happy to answer all your questions and other stuff. Good, thanks and goodbye.